So this video is on differentiating exponentials and logarithms. So we just need to remember these three rules because obviously when it comes to differentiating exponentials and logarithms, we keep using these three rules. So the first one is about when you differentiate an exponential function, and the second one is when you have the natural logarithms of something, and the third rule, which is the one that sometimes some students forget to just use how to use that, is basically when you have a function in this form, y is equal to a to the power of kx. And remember that whenever you want to differentiate a function like this, the first thing you do is just write down the function. So whatever you have, just write down f of x. And the second thing you do is that you say f of x times just your function times. So let's call the power of your exponent. Let's just call that g of x. And what you do as a result of that is, once you've written f of x times g dash x, which means the derivative of your power, times natural logarithm of your base. So yeah, that's one way of remembering this rule. So now let's try all of these and just apply all these rules. Okay, so in part A we have a function which is 4e to the 7x. Right, so this is of the first type, and if we want to differentiate this, that's going to be the derivative of the power times the function, and that's it. So the derivative of power is 7, because 7x differentiated to 7, which means that 7 times 4e to the 7x, and that's equal to 28 7x. Sorry, 28 to the 7x. And in part B, we have y is equal to 3 to the x, which is of the third form. And using the same thing again, so we start by writing down dy dx is equal to, we start by writing down the function. So let's just write down the original function, so 3 to the x, times the derivative of the power. So the derivative of x is just 1, and then times the natural logarithm of your base, which is 3. And this is going to be, just simplifying that, is going to be 3x natural logarithm of 3, and that's it for this one. Okay, part C is y is equal to half to the x. So this is again from the third type, and it's going to be, first of all, writing down dy dx is equal to, so we start by writing down the function, then times the derivative of the power, which is 1 again, times the natural log of the base, which is just this. And simplifying that, that's going to be equal to half to the x times natural log over half. Right, now let's do D, which is y is equal to natural log of 5x. So whenever you have a function in this form, y is equal to natural log of f of x, then always the derivative of that is going to be a fraction that the denominator is the function and the numerator is the derivative of the function. So let's now put that into practice and see what's going on. So in this case, we have y is equal to natural log of 5x. So using the same technique, dy dx is equal to Now it's going to be a fraction, so the denominator is just a function which is inside the bracket, so that's 5x, and the numerator is just the derivative of inside. So the derivative of 5x is 5. And this can be simplified, which gives us 1 over x, and that's it. Okay, now let's do e, which is y is equal to 4 times a third to the x. So this is of the third type, and the derivative of this is equal to, again, writing the whole function, which is 4 times 1 over 3 to the x, times the derivative of the power, which is just 1, times the natural log of our base, which is this. And now let's simplify this. So this is going to be, so 4 is not included as your base. So 4 is not the base. That's only going to be natural log of a third. Yeah, so obviously we can simplify this, and also we can leave that in this form, but let's just simplify that. So this can be written as, so let's just write here. So this can be written as 4 times natural log of a third times a third to the x. And yeah, we can leave that in this form. We can go further because natural log of a third can be written as 3 natural log of 3 to the power of minus 1. And then that minus 1 can come outside, which will be minus 4 natural log of 3 times this. But I think there is no need of doing that. So let's just move on to the next question. So this time we have natural log of 2x cubed. So this is of this type that I've written here, and the derivative of this is just going to be a fraction, and the denominator of that is going to be the function which is inside the bracket, so 2x cubed, and the numerator is the derivative of this inner function, which is the derivative of 2x cubed is 6x squared. And this can be simplified, which can be written as, so 6 divided by 2 is 3, and x squared divided by x cubed, so 2 of the 3 of this will be cancelled out, so that we won't have any x's on top, and we will be left with a x in our denominator. And now part G. So this is of the first type, so the derivative is equal to, so the derivative of powers times the entire function. That's what we do whenever we have e to the power of something. So the derivative of 3x is just 3, so that 3 times the entire of that function, 3 times e to the 3x. And here we have minus 3x differentiates to minus 3, so minus 3 times minus e to the minus 3x. Okay, now let's just simplify that. dy by dx is equal to 3e to the 3x, and here is going to be plus 3e to the minus 3x. Yeah. And finally h, which is 1 plus e to the x squared over e to the x. Okay, so it's better to start by expanding the top bracket. So denominator stays just as it is, and numerator is going to be 1 plus 2ex plus e to the 2x. So I just use the identity for expanding this bracket. And now remember that whenever we have a fraction, and we can basically set a split the fraction into several parts. So depending on the number of numerators, in this case, we have 3 terms in our numerator, so that we can split this one fraction into the sum of 3 fractions, which, add up to this fraction. So we can rewrite that as 1 over e to the x plus 2e to the x over e to the x plus e to the 2x over e to the x. So as you can see, we have a common denominator of e to the x. And if we add up all of these, that's going to be equal to this fraction. Okay, now let's just simplify each of these, and then we will start differentiating. So y is equal to 1 over e to the x can be written as e to the minus x. So 2e to the x divided by e to the x is going to be just plus 2. And finally, e to the 2x divided by e to the x, which is going to be plus e to the x. Right. Now we can start differentiating this function. So we can start by writing that dy by dx is equal to, so e to the minus x, so the derivative of the power is just minus 1 times the entire function. So 2 just differentiates to 0, constants differentiate to 0. So we don't need to worry about this. And e to the x, again, is going to be, so the power differentiates to 1 times the entire function. Okay, just simplifying this, and that's going to be the final answer of this question. So it's going to be minus e to the minus x plus e to the x. And that's it. So as you can see, for some questions like H, it's better to do some simplifying first and then differentiating that. And that's it for this video. So if you found this helpful, please subscribe to my channel for more videos. Good luck.